In this lesson, we are going to review how to solve 2x2 systems. And 2x2 systems means two equations and two unknowns, two variables. Later in the Algebra 2 year, we are going to do 3x3, three equations and three variables. But in order to do that, we have to be experts at solving 2x2 systems. So that's how we're going to start. And so there's multiple methods, one method being substitution. And so with the substitution method, you are substituting one variable. And so I like to organize this in columns. And so the idea is you want one variable already solved for. In this case, we already have y solved for. It says y equals 3x. And so I write down that equation, and then I make a column, and then I write the other equation in the other column. Okay, and so y is the variable that's already solved for. And so I highlight him. It's kind of like subbing a player out of a game. In, say, like a volleyball game, you can sub a player out. Y is the player getting subbed out of the game. And this 3x is the player that's going into the game for y. And so the first thing we're going to do is take y out of the game. And I leave a blank set of parentheses where he used to be, because that's where 3x is going to go to take his place. And usually we have more terms, and we would need to distribute the two. And so here we just have to multiply the 2 times 3x to simplify this. Then combine our like terms, and then divide by 11. So the point of this substitution is to have only one variable in our equation. When we sub out this y, we now only have x's in our equation, and we can solve for it, which we just did and got x equals -4. But we're not done. We still have to go back and get y, which is why I like this organization, because it kind of reminds you to go back and figure out what y is based on what you just found for x. We found x to be -4. So I can replace x with -4, which would give me y equals -12. And so your answer is usually an ordered pair, x comma y, or alphabetical order if you're not using x and y. And so our solution to this system is -4 comma -12. Put your x before your y. Okay, this next problem, x is the variable already solved for. So my bottom equation goes in the left column, and my top equation goes in the right column. And so x is the player getting subbed out of the game. 4y plus 6 is the player going in. And so we're going to take x out of the game. And this 4y plus 6 is going in. Okay. And then we can distribute the 2, so we can solve for y. So we get 8y plus 12. We can combine our like terms. We have 8y and 4y, which would give us 12y. And then now to isolate the y, we would first subtract this 12, and then divide by 12, which gives me y equals 1/2 when I simplify that fraction. Okay, so that's just our y value. We have to take that and go get what x equals. And so now that we know y is 1/2, we can substitute it. 4 times 1/2 is 2, plus the 6, so x is 8. And so my final answer, x comma y, would be 8 comma 1/2. Okay, so that substitution, it's very useful when one of your variables is already solved for. If you don't have this setup, you can make that setup by solving one of your equations for a variable. But we do have another method called elimination. And so elimination works when you have both of your equations in standard form so that your x's are lined up, your y's are lined up, and your constants are lined up. Okay, you need that set up because what you're going to do is you're going to add the equations together, and you want to create a situation where one of the variables cancels out. And so right now, if I were to add 4x plus 2x, I would get 6x. 3y plus y is 4y, so none of them canceled out. And so what we're going to do is we're going to scale one of the equations. So I'm going to scale the bottom equation by a -3. The reason why I'm choosing -3 is because then this y would have a -3 and the y's would cancel. You could also choose to multiply it by -2 and then this x would have a -4 to cancel. So you get to pick. And so I'm going to cancel the y's. And so if I multiply by -3, you have to multiply all 3 places. And so my new bottom equation becomes -6x minus 3y equals -21. Okay, and then I like to write the top equation right below it so they're right next to each other. And then now we're ready to add them together. -6x plus 4x is -2x. -3y plus 3y cancels like we wanted. And then -21 plus 9 is -12. And then we're ready to solve for x by dividing by -2. Okay, and so we have our x value, but we need to go back and find y. So pick either of your equations, whichever one looks simpler to you. I think this bottom one looks simpler. You'll get the same answer either way. 2x plus y equals 7, but now we know x is 6. And so that says 12 plus y equals 7. We can subtract 12 from both sides and get y equals -5. And so my final answer, x comma y, would be 6, -5. And a good way to check your work on these, and even the ones above, is to plug these back in for x and y into your system and see that they satisfy both equations. So for example, my top equation is 4x plus 3y equals 9. When I substitute the x and the y values I just found, I should get a true equation. 4 times 6 is 24. 3 times -5 is -15. And 24 minus 15 is 9. So that one worked. And then I can quickly check the second equation, which says 2x plus y equals 7. And so subbing the 6 for the x and the -5 for the y, I get 12 minus 5, which is 7 equals 7. So if you're ever wondering, or even on a test, if you have time, check your work. Okay, on this next example, be careful because the x's and y's are not lined up. So the first thing you want to do is rewrite this equation so that the bottom equation switches the x and y's. So we need the 4x, then the -2y equals 4. And so I think the easier thing to do is multiply this top equation by -4 so that the x's will cancel. If we try to cancel the y's, it's going to be harder to get a 0 pair because we'd have to change both equations. If I change the top equation to -4, I only have to change the top equation. Okay, and so distributing a -4 to all 3 places would give me -4x minus 12y equals -32. And then I'm going to copy the second equation right below it. And then we are ready to add. I always do this big bracket just because usually systems have these big brackets. And so x's cancel just like we wanted. and we're left with negative 14y equals negative 28 when we add up the y's and the constants. And then we can divide by the negative 14. We get y equals positive 2. Go back to the beginning and pick your favorite equation. I like this top one the best, but either one will work. X plus 3y equals 8. And then now we can replace the y. Be careful. Don't replace the x. We found y. And so x plus 6 equals 8. Subtract your 6, and we get x equals 2. And so my final answer is 2, 2 as an ordered pair. Now, some fun application problems that show up on SAT and PSAT and even in this class on a test or quiz is they'll give you two equations like this, x plus 2y equals negative 2 and x minus 2y equals 6, and then ask you to find the value of 2x plus y. So technically you do need to find x and y first. And so I'm going to set up my system. And then they're already ready to be added. When I add them together, the y's cancel. And gives me 2x equals 4. Now you could keep solving for x, but look at the goal. We're not just trying to find x comma y, we're trying to find out what 2x plus y is. And so we already know that 2x is 4. And then now we just need to know what y equals. And so I guess for this particular problem, we do need to go ahead and find out what x equals. And so x equals 2. Pick either equation. I think I'm going to pick this one. 2 minus 2y equals 6, because x is 2. Subtract 2 from both sides. Divide by negative 2. And we get y equals negative 2. So 2x is 4, and then y is negative 2. And so this becomes 4 minus 2, which is 2. And so just be careful for what the question is asking. They weren't just asking for x comma y. We found it in this case, but then we had to go answer what this expression was. And then oftentimes on PSAT and SAT, you don't actually have to find what these values are. It kind of just falls. Like if it just asked what 2x was, I could have stopped at this right here.